coefficient of performance, that is Q2 by W, which is called beta, that is given T2, you have to convert it to Kelvin, divided by T1 minus T2. Q2 by omega, Q2 by W equal to coefficient of performance, that is equal to T2 by T1 minus T2, but T2 is, since it is given in Celsius scale, you have to convert it to Kelvin. But in the bottom, no such 273 is required because there is a difference, and difference will become same. Now, Q2 can be written as Q1 minus W divided by W. Q2 is Q1 minus W. Then it will become T2 plus 273 by T1 minus T2. Then from this we can write Q1 by W minus 1 equal to T2 plus 273 divided by T1 minus T2. From this, calculate the ratio Q1 by W. That is required in the problem. So you have to find out the value of Q1 by W. So this one should be taken on that side and add, because that is the heat delivered to the room for each joule of electrical energy consumed. Q1 is the heat delivered to the room and W is the work done. So heat delivered for each joule. So it will be T1 plus 273 by T1 minus T2 when you add this one on that side. Minus T2 plus T2 will cancel and it will be T1 plus 273 by T1 minus T2. So option 2 is correct. Next one is easy. Will you come back again? Next question. We can write that P by rho is the density of the gas. This is equal to RT by molecular weight. Molecular weight of the gas, MW. Okay. So from this we can write rho equal, this is one form of the equation of state. Then rho equal to P MW divided by RT. This P, now MW means mass of the each molecules into Avogadro number, Na, and R equal to Kna in terms of Boltzmann constant. R equal to Kna. So the answer is Pm by Kt, option 2. Okay. Now question number 20. Solve. See, a body of mass m is attached to the lower end of a spring whose upper end is fixed. The spring has negligible mass. When the mass m is slightly pulled down and released, it oscillates with a time period of 3 seconds. When the mass m is increased by 1 kg, the time period of oscillation becomes 5 seconds. The value of m that you have to find out. See. We know that T equal to two pi root m by k for spring. Okay. So in the first case it is said that the time period is 3 seconds. So this is 3, this is 2 pi root over of m by k. This is my first equation. Next, the mass is increased by 1 kg. Mass is increased by 1 kg, so time period becomes 5. So it will be 2 pi root over of m plus 1 by k. Now divide these two equations, k will be eliminated and you can find the value of m.
So we can also write P is direct proportional to root m.
So if I divide equation 2 by equation 1, then it will be 5 by 3 equal to root over of m plus 1 by m. That is 25 by 9 equal to m plus 1 by m. 25m equal to 9m plus 9. That means 16m equal to 9 or m equal to 9 by 16. 9 by 16 kg. 21. Do it. See, it is said that second overtone of an open organ pipe. In open organ pipe, second overtone means third harmonic. That is 3n 0. 3n0. Okay, for open pipe, I consider n is the fundamental frequency. NO stands for open pipe. Second overtone means third harmonic, because n, 2n, 3n, it goes like this. Then it is equal to the first overtone of the closed pipe. In first overtone of the closed pipe, n, then 3n. So again this 3n for closed pipe. Okay, because in the closed pipe only odd number of overtones are present, odd harmonics are present. So fundamental, then first overtone. First overtone is third harmonic actually in case of closed pipe. So this not 0, this stands for open pipe, this stands for closed pipe. Then 3 will cancel. Then simply put NO for open pipe. That will be V by 2LO. Length of the open pipe will be, closed pipe's length is given. So this one will be V by for L. So LC is given L itself. So L of length of the open pipe equal to 2 times the length of the closed pipe. Okay, length of the open pipe is 2 times the length of the closed pipe. Next, 3 sound waves of equal amplitudes have frequencies n-1, n+1. They superimpose to give beats. The number of beats produced per second will be. You have to calculate the difference between the maximum frequency and minimum frequency. That is 2. Maximum is n+1, minimum is n-1. Their difference will be the number of bits produced. Just use this formula, tau equal to Pe sin theta. Okay, because you have given that the torque is given, tau equal to Pe sin theta, but P can be written as Q into D sin theta. Then calculate Q from that. Torque is given 4 Newton meter. D is given 2 centimeter. You have to convert it into meter. Then field intensity given 2 into 10 to the power 5. Angle given 30 degree. Calculate. What is the answer? 2 milli or micro? Milli, sure. K1, K2, K3, K4. This is A. This entire thing is D. This is D by 2. A by 3 each. A by 3. Now, you have to find out the relation which one is correct, that is for the equivalent dielectric constant. Okay. Now see, we can consider there are 4 capacitors together. Now at this point, on this line and on this line, potentials are same. Means we can say that these 3 capacitors are connected between same potentials. Okay, so they are connected in parallel, same potential. This line and this line have the same potential. A particular horizontal line have the same potential. So these 3 are connected in parallel between the same potentials. So what will be their equivalent capacitance? That we will only find. So let us consider its capacitance is C1, its capacitance is C2, its capacitance is C3, and its capacitance is C4. So since this C1, C2, C3 are in parallel, their equivalent capacitance, say C prime, that will be C1 plus C2 plus C3. Okay. Now we will draw the diagram again like this. Now we will consider that this one is a single capacitor having capacitance C prime, and this one is C4. Okay, clear? So C1, C2, C3, they are replaced by a equivalent, that is C prime, their parallel equivalent. And then we consider that C prime and another C4 are connected in series, because from this potential, if charge goes to this, then same charge will flow through both of them. So now C prime and C4 are connected in series. So their equivalent will be 1 by C equal to 1 by C prime plus 1 by C4. Clear? 1 by C prime plus 1 by C4. Okay? Now, what is C1? C1 is epsilon naught A by 3 by D. See, epsilon naught A by 3 by D. This is the expression for C1. Clear? So actually I can write this by 3 in the denominator. So it is actually epsilon naught A by 3D. Similarly, C2 equal to epsilon naught, sorry, here is K1. C1 is K1 epsilon naught A by 3D. Similarly, this one will be there is this K1, here is K2 epsilon naught A by 3D, and similarly then C3 is also same, K3 epsilon naught A by 3D, because area is A by 3 for each. And now C4 is K4 epsilon naught A by now these are actually D by 2 each. So D by 2 means there will be 1 2 factor here, 2 2 2. Distance is D by 2. C1 is then K1 epsilon naught A by 3 by D by 2. So 2 will come in the numerator and 3 will come in the denominator. Okay. So C2 will be 2K2 epsilon naught A by 3D. C3 equal to 2K3 epsilon naught A by 3D. C4 area is A but length is D by 2. So it will be K4 epsilon naught A by D by 2, which can be written as 2K4 epsilon naught A by D. Now I will substitute all these values there. C 1 by C, so we will put its value later. 1 by C prime. What is C prime? C1 plus C2 plus C3. Now C, check all this. Which can be taken common? 2 can be taken common, epsilon naught common, A common, 3D common. So I can take 2 epsilon naught A by 3D entire common into K1 plus K2 plus K3 plus 1 by C4. So 1 divided by C4. C4 is 2 K4 epsilon naught A by D. Okay. Now, what you can write for this C? Then if I consider that entire combination is replaced by a single capacitor, then that is called the equivalent. So for the equivalent, area is A, distance is D. So we can write for the equivalent 1 by K epsilon naught A by D. K epsilon naught A by D. Now see, epsilon naught A by D. From these two expression, you can take epsilon naught A by D common, and this part epsilon naught A by D will cancel. Then after that, 1 by K, this term after cancelling will be 3 by 2 K1 plus K2 plus K3 plus 1 by 2 K4. Then take the both of these two common and multiply here. Using Kirchhoff's law, we can write VA, then minus of 2 into 2, that is 4, minus 3, minus 1 into 2, that is 2, equal to VB. I covered the loop in anti-clockwise. If I consider like this, cover the loop in anti-clockwise sense. So I am going opposite to the current. So potential drop for the resistances are considered as the negative, and for the cell I am going from negative to positive. So that's why minus. So from this you can write VA minus VB, that is required in the question, which is equal to 9 volt. Next question, solve. First calculate the resistance of the filament of the bulb. Okay. What is the resistance? You don't know. All the data are given. Calculate. Rating of the bulb is given 500 watt 100 volts. From that calculate the resistance of the bulb first. See, P equal to V square by R. So R will be V square by P. So this R for bulb, this one will be voltage is 100 into 100 by 500. So 20 ohm. Now it is connected in series, okay, with another resistance capital R. Then the circuit looks like this. This is the bulb, this is another resistance. Suppose R, this is RB. It is connected with a 230 volt main, okay, and it is said that it works perfectly. Means bulb will again draw how much voltage? 100. So voltage across the bulb will be 100 volt when it is connected with 230 volt main with this resistance in series. Means from 230, 100 is taken by the bulb, then voltage across this one will be remaining 130. So voltage across this one is 130 volt. And since both of them are connected in series, then current through them are same. So from that I can write that voltage across the resistance 130 equal to current through the resistance into resistance, unknown resistance. Similarly, voltage across the bulb equal to current through the bulb into resistance of the bulb. Then divide these two. 130 by 100 equal to R. RB is already found, 20. Calculate. So R equal to 26 ohm. Okay. So what we have done? First we calculate the resistance of the bulb, then it is 20 ohm. Then we consider that if this bulb is connected in series with a resistance R and entire circuit is connected with a 230 volt supply, then bulb works perfectly. Means it will draw the same voltage. So that is 100 volt. Then remaining 130 volt is across R. Then since they are connected in series, current through them are equal. So 130 volt is the voltage across this resistance, that will be equal to current through the resistance into resistance. Similarly, 100 volt is the resistance across the bulb, that is equal to current through the bulb into resistance of the bulb. Then I divide this two to cancel this I, and RB is already calculated, 20. So you have to find out the unknown resistance R. Next one is very easy, do it. See, we know that B for one turn it will be mu naught one turn, and turn is here given, say n into I. Mu naught I by 2R. Okay, for one turn it is mu naught I by 2R. Now n turns are made with the same wire, then we can say that the total length of the wire is 2 pi r. So previously that is 2 pi r. This is the length of the entire wire in one turn. Then suppose r is changed to r prime, so it will be n times 2 pi r prime, because n turns are now prepared with the same length of the wire. So it will be n into 2 pi r. Then 2 pi cancels, so we can write r prime equal to r by n. R prime equal to r by n. Now new magnetic field B prime, if there are n turns, then current will be multiplied by n times, then it will be mu naught Ni divided by r prime, 2 into r prime. Now substitute the value of r prime. Okay, so if you substitute the value of r prime, it will be mu naught n square I by 2r, but mu naught I by 2r is already B, so it will be n square times B. Because when you change the number of turn, the radius will change as well as current will change. So current will be multiplied and radius will be divided. Because length of the wire remains same. Previously you prepare one turn, now you prepare n number of turns. And here length means the circumference of the circle. Next one is also very easy. A bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field and is in equilibrium state. The energy required to rotate by 60 degree is W. Now the torque required. See, you can write the two formulas, that is W equal to mb sin theta. No, W equal to mb cos theta. mb cos theta, and torque tau equal to mb sin theta. Then divide these two, then tau by W will be equal to tan theta. Okay, theta is given 60, so tan 60 is root 3, so tau equal to root 3 W. Work done is mb sin theta, torque is mb, work done is mb cos theta, torque is mb sin theta. Second one is also direct formula. Just use this, F equal to QB by 2 pi m cyclotron frequency. Just put the values. Magnetic field strength given, E by m ratio. Q is E actually. So Q by m is E by m ratio. Electronic charge is denoted by E. So this Q is actually E. Okay. So E by m ratio given, B is given, then divide by 2 pi and find frequency. Quality factor Q equal to 1 by R root over of L by C. And you have to check all this separately to calculate the quality factor for the 4 options. Whichever is the highest quality factor, that is the answer. Better communication means resonance curve is very sharp. Sharp resonance curve means highest quality factor. This is the formula for quality factor. You have to find out highest quality factor of the combination among the options. Next one, that is also very easy. It is said that in the loop 1, magnetic field is changing at a rate of dB dt. Okay. Then we know that EMF induced E equal to minus d phi dt and phi equal to B into A. And through the loop, magnetic field is going, lines are going perpendicularly. Perpendicularly means angle between field lines and area vector is 0 degree, not 90. It is lines are perpendicular to the plane of the loop. That means area vector and field lines are along the same direction. So the angle is 0 degree, remember. So it will be B into A, cos 0 is 1 divided by dt. So B is variable, area is constant. So I can take this one out and this will be dB dt. And what is the area through which lines are passing? Small r, pi r square. So A will be minus pi r square dB dt. Okay. This is the EMF generated in the loop 1. Because through the remaining area of the loop 1, field lines are not going. Then none of the lines are going through loop 2. So loop 2 magnetic field is passing through the loop 2 is 0. So the EMF induced in the loop 2 will be 0. So option 4 is correct. Because magnetic field only passes through loop 1 and it changes. Through 2 no magnetic field passes. So no question of change or anything. Okay. Then 32. The potential difference across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit, the power factor of the circuit. See, we know that tan phi equal to XL minus XC divided by R. XL minus XC by R. Okay. Then if I multiply numerator and denominator both by current, because same current flowing through each of them, because they are connected in series. So I can write IXL minus IXC by IR. So this will be voltage across L minus voltage across C by voltage across R. Okay, then potential difference across resistance is given 80, so VR is 80. Across capacitance and inductance 40 100, so this one 100, this one 40, so this is coming 60 by 80. 60 by 80 means 3 by 4. Tan phi is 3 by 4. Then find the value of cos phi. Cos phi will be 4 by 5 then. That is 0.8. See, this is the structure. This is one convex lens. This is another convex lens. Okay, their focal length are given equiconvex both, and their focal length are given each f. Now this portion is filled with water. So we can consider that there are now three lenses. First one is a convex equiconvex lens made of glass, then an equiconcave lens made of water, then another equiconvex lens made of glass. Okay, so now individually I will calculate the focal length of all these three and add. Combination of the focal length I have to find out using the formula 1 by f equal to 1 by f1 plus 1 by f2 plus 1 by f3. Clear? Now, so for the first one I consider that focal length is f1. For this one I consider the focal length to be f2. This one I consider the focal length to be f3. Later f1 equal to f, f3 equal to f, that we know. Now, see, for this, two equiconvex lens, we know that 1 by f equal to mu by mu2 by mu1, that is 1.5 by 1 minus 1 into 1 by r if radius of curvature of each surface is r. Then second one is 1 by r also plus 1 by r, because 1 by r1 minus 1 by r2, r1 and r2 according to the sign convention r2 sign will be negative in this case, so it will be 2r. So it will become 1 by f equal to 1 by r, so f equal to r. Focal length and radius of curvature will be same. Okay. For glass lens, glass equiconvex lens in air, this is the calculation. Okay. Now, we consider the equiconcave lens made of water. So for that, if focal length is f2, suppose we consider, then it will be mu2 by mu1. Now mu2 is 4 by 3 by 1 minus 1. Now 1 by r1 minus 1 by r2. Since it is equiconcave, then this one will be minus r, next one will be same minus r. Equiconcave. Okay. Then we can write 1 by f2, this is equal to 4 by 3 minus 1. 4 by 3 minus 1 will be 1 by 3 and this one will be minus 2 by r. So we can write 1 by f2 equal to minus 2 by 3r. Okay, but we already know that f equal to r, so I can put it here and it will become minus 2 by 3f. Okay, minus 2 by 3f. So I calculate the focal length of each length in terms of f. Then use this formula, 1 by f equivalent equal to 1 by f1 plus 1 by f2 plus 1 by f3. Now 1 by f equivalent will be 1 by f, this one 1 by f2 means minus 2 by 3f, that is again 1 by f. Calculate f equivalent. So from the length maker's formula you will find all this f1, f2, f3 and then substitute in the form 1 by f equivalent equal to 1 by f1 plus 1 by f2 plus 1 by f3. That power is additive. So it will come 3f by 4. Complete the calculation. Centimeter deep, a 3 centimeter deep when viewed from the opposite surface. The thickness of the slab is, see, the observer is in the rarer medium and the bubble is in the denser medium. So what you will see that the real depth and apparent depth problem, and real depth is more than the apparent depth. Okay, so what you can see here is the apparent depth because you are looking from the rarer medium. Now we know that d apparent equal to d real by mu. Now see the situation. This is the slab. Suppose this is the position of the bubble. So when you look from this side, say the real depth is dr1. When you look from this side, the real depth should be dr2, but you are looking from both sides and you are getting the apparent depth. So I can write that d real equal to mu into d apparent. So I can write mu into d apparent 1 plus mu into d apparent 2. That will be the this real depth plus this real depth, that is dr1 plus dr2, which is equal to the total thickness of the slab. Okay, total thickness of the slab is the sum of the two real depths from both the sides, this one and this one. So it will be dr1 plus dr2. This r1 and r2 are actually suffix, d real 1 plus d real 2. Now this will be mu times d apparent 1 plus d apparent 2. So mu common, just calculate this, d apparent 1 plus d apparent 2. Mu is 1.5, that is 3 by 2, and others are given 3 and 5. So this one is 5 plus 3, that is 8 by 2, 4, 12. So it is 12 centimeter. Okay. So this is the thickness of the slab. So two apparent depths are given, you have to find out two real depths and add 2. Then question number 36. We know that intensity I equal to I1 plus I2 plus 2 root I1 I2 cos delta. Delta is the phase difference. Okay. Now maximum intensity means this cos delta is plus 1. So it will be root over of I1 plus root over of I2 whole square. Similarly, minimum intensity will be when cos delta equal to minus 1, it is root I1 minus root I2 whole square. Okay. Now here it is given that intensity ratio is given n, that is in the problem I1 by I2 this ratio is specified as n, and you have to find this value I max minus I min by I max plus I min. Okay. This root I1 and root I2 just like a and b, a plus b whole square, and this is a minus b whole square. So I max minus I min means a plus b whole square minus a minus b whole square, that is 4ab. So it will be 4 root I1 root I2. Clear? 4 root I1 root I2. And I max plus I min is just like a square, a plus b whole square plus a minus b whole square, means 2 times a square plus b square, but a is root I1, so its square will be I1 plus I2. Okay. Then it comes 2 cancel. Then divide numerator and denominator both by I2. What you will get? Check. 2 root over of I1 by I2 divided by I1 by I2 plus 1. I divide numerator and denominator both by I2. So if you divide this term by I2, then it will be root I2 by I2, means 1 by root I2. So a root over of I1 by I2 come in the numerator, and in the denominator this one. Now I1 by I2 is given n. Substitute. It will be 2 root n by n plus 1. Okay. This is from the interference of light, this question. Then next one, 37. See, a person can see clearly objects only when they lie between 50 and centimeter and 400 centimeter in order to increase the maximum distance. That means that 400 centimeter has to be increased. Up to what? Because for a normal human eye, the far distance of distinct vision is infinity and near distance is 25 centimeter. So far distance have to be corrected. Okay, which comes to 400, we have to send it to infinity. So that means the myopia correction is required. Myopia correction is required. Okay, then 1 by V minus 1 by U equal to 1 by F. What is V? V should be at 400 centimeter. 400 centimeter means 4. And this one is infinity. This is 1 by F. But since this one will be minus, according to the sign convention, this 4 will be minus 4. So F will be 1 by F. What you have to calculate? Power. So power P equal to minus 1 by 4 means 0.25 diopter. Minus 0.25 diopter. That is, concave lens is required with minus 0.25 diopter power. Because for the calculation of the power in diopter, you have to convert the focal length into meter. So that's why 400 is converted into meter, and then we substitute with the proper sign. So the logic is that if you use this spectacle with this power, which will produce this particular focal length, then object which is at infinity, its image will be produced at 400 centimeter such that you can see, because your far point comes to 400. So the object at infinity should produce its image at 400. Then you can only see. So that work is done by the spectacle. A linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated normally by a parallel beam of wavelength, the distance of the first dark band of the diffraction pattern y equal to lambda d by a. Y equal to lambda d by a. That y you have to find out. Lambda is given 5 into 10 to the power minus 5. A is the width given, and capital D is given 60. Because y by dx is actually sine theta. So a sine theta equal to n lambda, n is 1. And then we put sine theta equal to this one, y by d. আসছে এর ভ্যালু তো দেওয়া আছে 0.02 অ্যাপারচার অফ দ্য ও এইটা আছে তো হাই So answer is 0.15 centimeter. Okay. Then electrons of mass m with de Broglie wavelength lambda fall on the target in an X-ray tube. The cutoff wavelength lambda naught of the emitted X-ray is. See. De Broglie wavelength we know lambda equal to h by p. Okay. Now we can write p equal to h by lambda. I will take a square on both sides. Okay. So p square equal to h square by lambda square, where this lambda is the de Broglie wavelength. Now P square can be written as 2m into kinetic energy. So it will be 2m into kinetic energy E. Then it is h square by lambda square. Okay. Now this electron falls on the target material, fall on the target in an X-ray tube, the cutoff wavelength of the emitted X-ray. So this should be the emitted X-ray's energy. This can be written as 2m into hc by lambda naught, that is the cutoff wavelength of the emitted X-ray. Okay. Because h e equal to hc by lambda, so it is h square by lambda square. Now one h will cancel, then lambda naught you have to find. Lambda naught will be 2mc by h lambda square. 2mc by h into lambda square. So first, using de Broglie wavelength, we have to find P, then taking a square, then we can put P square equal to 2me, where E is the energy of the emitted electron. So then we can write emitted X-ray, energy of the emitted X-ray. Then we can write that E equal to hc by lambda naught. hc by lambda naught. Lambda naught is the cutoff wavelength. Then photons with energy 5 electron volts are incident on a cathode C in a photoelectric cell. The maximum energy of the emitted photoelectrons is 2 electron volt. When photons of energy 6 electron volts are incident on C, no photoelectrons will reach the anode if the stopping potential of A relative to C is. See, first we use this relation half m v max square equal to E minus work function. Okay. Then photons with energy 5 electron volts are incident on a cathode. So this E is 5 electron volt, and maximum energy of the emitted photoelectron is 2 electron volt minus W. So we can write W equal to 3 electron volt work function. Okay. Now we can write that EVS equal to E minus work function. Now in this case I will consider it is just E prime. Okay, because it is different from previous, that is 6. So now this one will be given 6 EVS minus it is 3. So EVS will be 3 electron volt, means stopping potential will be 3 volt. Then the stopping potential of A relative to C is required. Stopping potential of the anode relative to cathode, that will be minus, because stopping potential should be reverse bias potential. Reverse bias potential which can stop the current. Okay, so that's why you have to put that minus sign. So it will be minus 3 volt. A relative to C, that's why it is negative. Next, 41. Calculate 41 data লাগবে। 6 দিন বাকি, 5টা পেপার। কারণ এটার পরে ইয়ারের পেপার আর 3টে থাকবে, আর তোমাদের এর মধ্যে আরও 2টো নতুন মক টেস্ট হবে। 5টা পেপার করতে হবে, হ্যাঁ, আর তার মধ্যে 6টা দিন আছে। আমি শুক্রবার সকালে যাচ্ছি, 5টা, ওই জন্য আমি স্লো যাচ্ছি। এমন কোনো কি পেপার মাঝখানে পরীক্ষা দিয়েছো যেগুলো নিট নয় 24-এর পর থেকে, যেটা খুব রেলিভেন্ট বলে মনে হয়েছে কোশ্চেন? মানে যদি থাকে তাহলে সেই পেপারটা ডিসকাস করব, কারণ 51টা যেটা ছিল না, 50টা, ওটা তো ইম্পসিবল, ওটা হতে পারে না, পেপার হবে না কখনো। মাঝখানে একটু দেখে আমাকে বলো, তাহলে যদি সময় থাকে তাহলে ওই একটা পেপার আমি ওই ডিসকাস করবো। একটু রেলিভেন্ট পেপার ডিসকাস করা দরকার। See, when the electron jumps from third orbit to second orbit, it emits photons of wavelength lambda. We know that 1 by lambda equal to Rydberg constant into z square into 1 by n1 square ni square minus nf square. Okay, so in the first case, jumps from third to second, that means 1 by lambda equal to r z square into 1 by 2 square minus 1 by 3 square. Then in the next case, suppose it will be 1 by lambda prime, it will be r z square into, from the fourth orbit to the third, that means 1 by 3 square minus 1 by 4 square. Okay, then take the ratio. So 1 by lambda divided by 1 by lambda prime, rz square will cancel, it will be 1 by 4 minus 1 by 9 minus 1 by 4 minus 1 by 9 divided by 1 by 9 minus 1 by 16. Now calculate lambda prime. So it will be lambda prime by lambda, it is 9 minus 4, and it is 9 into 16, 16 minus 9. So lambda prime by lambda equal to 5 by 36 into 9 into 16 by 9 minus 16 is 7. Start question number 1. NEET 3, mock NEET 3. dimension of surface tension. Surface tension means force by length. Okay, so this should be given proportional to say e to the power x, v to the power y, and time t to the power z. Then you have to find the dimensional formula for surface tension. Okay, then we know that this side have a dimension force have a dimension ml t to the power minus 2 divided by L. So L will cancel, so it will be m t to the power L to the power 0 and t to the power minus 2. Okay, and here it is m to the power 1. Then it is proportional to e to the power x. E means dimension is m L square t to the power minus 2 to the power x, means m to the power x, L to the power 2x, t to the power minus 2x. Similarly, v is L t to the power minus 1 to the power y, means L to the power y, t to the power minus y, and time is same, t to the power z. Then we can write m to the power 1, L to the power 0, t to the power minus 2, that will be proportional to m to the power x only, L to the power 2x plus y, and t to the power minus 2x plus z. Okay, minus 2x, oh, another is there, minus y is also there, minus y, minus 2x minus y minus plus z. Then equate the powers. Equating the powers of m will give you x equal to 1. Equating the powers of L, you can write 2x plus y equal to 0. 2x plus y equal to 0. X is 1. So if you put, so y will be minus 2. Now from the third we can write minus 2 equal to minus 2x minus y plus z, and just substitute the value. Minus 2, x is 1, so it is minus 2, y is minus 2, so it will be plus 2 plus z. So plus 2 minus 2 cancel, so z will be minus 2. So which one is correct? X equal to 1, y equal to minus 2, z equal to minus 2. So that is option 3 is correct. E v to the power minus 2, t to the power minus 2. E v to the power minus 2, t to the power minus 2. Next, a ship A is moving westward with speed 10 km per hour, and a ship B 100 km south of A is moving north with a speed of 10 km per hour. The time after which the distance between them becomes shortest. First ship moving west with speed v. Next ship is initially at this distance, say d, initially at a distance d, and now it is start moving along this direction with same speed. Speed is same, v, it is moving. Now let us consider after time t, distance between them is something. After time t, this ship reaches here and this ship reaches here. Okay, so after time t, this distance should be vt, this distance should be vt. Now the distance between them, this line, let it be x. Okay, then I can write that this distance is d minus vt. This distance is d minus vt, and this distance is already vt. So using Pythagoras theorem, I can write Pythagoras theorem, or better to not to write d, this one, because I will differentiate. So again there may be a confusion with this distance d, so I will make it L. Okay, I will write this one as L. Then this is 90, so Pythagoras theorem will tell you that x square equal to v square t square plus L minus vt whole square. Okay, x square equal to v square t square plus L minus vt whole square. Now you have to find the shortest distance between them, means x is shortest, means x square is also shortest in that case. So I will differentiate d of x square dt. ddt of x square I will calculate and set equal to 0 for maximum minimum. Okay, so it will be v square will be there, derivative of 2t square is 2t plus this quantity's derivative, it will be 2 into L minus Vt. Then L minus Vt's derivative is required. L minus Vt, L is constant, its derivative is 0, and this quantity's derivative will be minus V. So you have to multiply with another minus V. Now put this one is 0. Okay, and then calculate the time. So 2 can be cancelled, then it will be v square t plus minus L into V plus v square t. Okay, so I take 2 common and divide on that side. So 0 by 2 is 0. So it will be v square t, and this term will be L into minus V, that is minus LV, and minus Vt into minus V, that means plus v square t. So from this I can write that LV equal to 2 v square t. So 1 v square you can v will can cancel, so t will become L by 2v. অ্যান্সার কত? √2 কি করে আসছে? টি তো কেটে যাচ্ছে, এল ইন্টু ভি 2 ইন্টু এল মাইনাস ভিটি স্কোয়ার টি স্কোয়ার 2v স্কোয়ার ইন্টু 2t প্লাস 2 ইন্টু এল মাইনাস ভিটি, এটাই আসছে। হ্যাঁ টি তো কাটছে। That distance is L minus VT. L পুট করলে কত আসবে? L হচ্ছে বলে যে 10 কিলোমিটার পার আওয়ার 100, T কত এখান থেকে আসছে? divided by 2 into 10, 5 আসছে তো। How that root 2 is coming? Time after which the distance between them becomes shortest, x square. কোনটা বলো তো, কোন ক্যালকুলেশনটা করলে তুমি? দাঁড়াও, আমার ক্যালকুলেশন তোমার ক্যালকুলেশনে কি ডিফার করলো? এক্স স্কোয়ার ইকুয়াল টু এল মাইনাস ভিটি স্কোয়ার, ভিটি স্কোয়ার তোমাকে কি বার করতে বলেছে? এইটা বার করতে? না তা তো নয় তো। দ্য টাইম আফটার হুইচ দ্য ডিস্টেন্স বিটুইন দেম বিকাম শর্টেস্ট, টাইম বার করতে বলেছে। না না, দ্য আনসার উইল বি 5 আওয়ার। এটা বোধহয় 5ই আসছে তো। আনসার কত আছে দেখো তো এই কোশ্চেনটা। ইটস 5 আওয়ার। এই তুমি এখানে টিক করে রেখেছো ভুল। হ্যাঁ, ও শর্টেস্ট ডিস্টেন্সটা বের করে ফেলেছে। Okay, then question number 3. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to Vx equal to beta x to the power minus 2n. Where beta and n are constant, x is the position of the particle, the acceleration of the particle as a function of x is given by. See, there are many ways to calculate this. V is given beta x to the power minus 2n. Okay, you have to find out acceleration as a function of x, not t. So I will do one thing, I will square on both sides. So v square will be equal to beta square x to the power minus 4n. Okay, now I differentiate both sides with respect to x. This term will be 2v dv dx. This is from the chain rule, because differentiate with respect to v will give you 2v, then we are differentiating not with respect to v, we are differentiating with respect to x. So another dv dx will come. On this side, beta square remain constant. This derivative minus 4n will come, x to the power minus 4n minus 1. Okay. 2, this 4 cancel, 2. Now v dv dx means acceleration. Minus 2n beta square into x to the power minus 4n minus 1. That is the answer. If you calculate dv dt from the first step, then on the right side you will have a term dx dt and again multiply with that v. You will get the same answer. So either calculate dv dt in that method, or taking a square then calculate then differentiate with respect to x. If force 14 Newton is applied on the 4 kg block, then the contact force between A and B is required. For calculating the contact force, what we will do? First, we will calculate acceleration. Acceleration will be simply total force divided by total mass. Total mass is 7, that is 2. Then you have to find the contact force. Then always consider the other part of the mass is only moving under this contact force. Because if you calculate the force on A, Newton, if you apply Newton's second law on A and calculate mass of A into acceleration, you will get the net force, not the contact force. Because block A is now here and these are the combination of the blocks BC. So contact force means there is R, there is reaction R, there is your applied force F. So if you calculate acceleration with this mass, you will not get R, you will get F minus R. Okay. So always to find, multiply the remaining mass, you will get only R, because R will be equal to mass of B plus C. Mass of B plus C is 2 plus 1, that is 3, 3 into 2, 6 Newton. From A you can also calculate. How? F minus R equal to mass of A into acceleration. Then you can also calculate. Mass of A is 4. This one will also come, but you have to calculate. But if you take the other portion, then you can find the answer directly. Okay.